Welcome back to WABC. So we can move to another interesting section called thermodynamics. Okay, in the view of exam, the total mark given to this thermodynamics is comparatively less, but it is very interesting and it is very simple. Okay, only just some mathematical calculation. So we can move to the first question. The ratio of molar specific heats of oxygen is. So we need to understand what is meant by molar specific heat capacities Cp and Cv. Heat capacity, molar specific heat capacity at a constant volume and a constant pressure. At constant pressure it is Cp and at the constant volume it is called Cv. So Cp by Cv, gamma is equal to Cp by Cv. Okay, and how we can find here the Cp and Cv and Cp by Cv. Cp and Cv of this oxygen is not provided. So how we can find? Another equation for the gamma is 1 plus 2 by F. F is the degrees of freedom. So how can we find the degrees of freedom of oxygen molecule? Since the classification made on the molecules are monoatomic, diatomic, mainly monoatomic, diatomic, and the triatomic and that kinds of molecules, we can leave that. Okay, for the basic parts we can only focus on monoatomic and diatomic. Okay, for monoatomic it is the degree is freedom is given as 3 to 1. In 3 dimension the degrees of freedom is 3, in 2 dimension the degrees of freedom is 2, and in 1 dimension the degrees of freedom is 1. But in case of diatomic, actually we can classify the entire diatomic molecule into 2 sections. First part is rigid and the second part is non-rigid. So in case of rigid diatomic molecule, that means the 2 molecules are not allowed to move away from each other. Okay, no vibrations are allowed. So 3 translation, like in 3 dimension in case of monoatomic, we find that the 3 is the degrees of freedom. Okay, addition to that, a 3 translation and 2 rotational degrees of freedom are added. So total 5. In case of non-rigid, a vibration is allowed. So 3 plus 2 plus 1, total 6 is given. Okay, so these are the degrees of freedom on the basis of the structure of the molecule. Okay, so in case of oxygen is diatomic O2 and they are rigid, so degrees of freedom is 5. So you can substitute F as 5. So 1 plus 2 by 5 is 7 by 5, which is 1.4. Okay, so option A is the correct answer. So whatever is the molecule, it can be helium or hydrogen or any kind of, it is monoatomic or diatomic. If it is diatomic, it is rigid or non-rigid. If it is, there is no idea about the rigidity, that means it can be rigid, it can be non-rigid. Then if there is no idea about the rigidity inside the question, so you can select it as a rigid molecule. Okay, so we can move to the next question. Okay, a solid cube of mass m at a temperature theta 0 is heated at a constant rate. It becomes liquid at temperature theta 1. That means a phase transition is taken place in here. That means it came from what? Solid, and it arrived at which state? In liquid. Okay, so from theta 0 to theta 1 and vapor state at theta 2. Then from theta 1 it traveled to theta 2 temperature by changing the phase also. Okay, the liquid is turned to vapor. Okay, Let S1 and S2 be the specific heats in its solid and liquid state respectively, and if LF and LV are latent heat of fusion and vaporization respectively, then the minimum heat energy is supplied to the cube until it vaporizes. Okay, so the solid, in case of solid, then to liquid, okay, then to gaseous. Okay, in here the solid want to be go to the liquid. So first of all, there is no temperature change for a what we can say, the ice crystal. Okay, so if we want to melt an ice, first of all the ice want to go from 0 degree Celsius or the -1 degree Celsius to 0 degree Celsius. Then at that temperature, at that particular temperature, it want to make the phase transition. That means solid to liquid. After that, after turning the 0 degree ice to 0 degree liquid, the liquid is getting the energy and increasing the temperature. So first of all, what we want to do, at a solid cube of mass m at a temperature theta 0 is heated at a constant rate, it becomes liquid. Okay, so what we have to do, first of all, we want a latent heat of fusion, MLF. Yes, there is MLF in the 3 equations. So first equation can be neglected, and we want a theta change, that means a temperature change with respect to the specific heat. So theta 1 minus theta 0 into ms1 is so we can cut the second equation, and then we want a latent heat of vaporization should be there. So okay, option C and option D have that, and in comparing the C and D, there is in C it is theta 2 minus theta 1, and in D it is theta 2 minus theta 0. So theta, why we want to take the theta 2 to minus theta 0? Theta 2 is the temperature after the vaporization. So we don't want to bother about theta 0, that when we reach vaporization. Okay, if we are in vaporization, we want to bother about only in the liquid state, the energy in the liquid and the energy in the vapor state. Okay, not bother about the energy in the gaseous state. Okay, so ms2 theta 2 minus theta 1 and ms2 theta 2 minus theta 0. Which one is the correct answer? ms2 theta 2 minus theta 1. Okay, so option C is the correct answer. Okay, so there is a phase change also, and there is an energy change also. Well, while the changing the energy, we want, while giving the energy, it will change from one temperature to the other temperature. Also the energy is used to take the transition from phase, that means liquid to gaseous, by staying in the same temperature. For water, for H2O, it can be we can find the same molecules at 100 degrees Celsius in different phase, that means in gaseous phase also and in liquid phase also. In case of 0 degree Celsius, we can find ice and water in 0 degree Celsius. Okay, so that's the difference. So we can move to the next question. 1 mole of an ideal gas, ideal monoatomic gas is taken. Okay, 1 mole, only 1 mole, taken around the cyclic process MnOM. That means it comes from the M and goes to N and then comes to O and then goes to M. That means a cyclic process. The work done by the gas, okay, by the law of thermodynamics, we know that dq is equal to du plus pdv. What is mean by this equation? The total heat is given to change the internal energy and to do the work. The first term represents the heat supplied by ourselves, okay, and du is the change in internal energy. Okay, this will change the term. Du means the change in internal energy, and pdv, that means P, pressure, into dV, the change in volume, that will make the work done. Okay, so this term is the work done. Change in work done is PdV. Okay, so the change in PdV gives the area under the graph. Okay, so what is the area under the graph? The length and breadth. Just find the length and breadth. 3V0 minus V0 is 2V0, and 3P0 minus P0 is 2P0. So 2P0 into 2V0 is 4 P0 V0, but it is a triangle, so divide by 2, so it is 2P0 V0. So option D is the correct answer. Okay, area under the graph of a PV diagram gives the work done. Okay, is it simple? Yes, it's very simple. Okay, okay, the PV diagram of a Carnot engine. Okay, this is the graphical representation of a Carnot engine is shown in the graph below. The engine uses 1 mole of an ideal gas at working substance. So N is equal to 1. Simple. From the given graph, the area enclosed by the PV diagram is, okay, then again the area enclosed by the PV diagram. The PV diagram, the area by the PV diagram is nothing but work. So actually the question is we need to find the work. Okay, so which are the equation which connect work? Here we have the data of pressure, and here we have the data of volume, and here we have the data of temperature. Actually the data of the temperature is not given, but we can find. How we can find the temperature and how we can connect the temperature with the work done? Okay, so for that I am writing an equation eta. What is mean by eta? Eta is given as the efficiency of Carnot engine. Okay, efficiency of Carnot engine is 1 minus T2 by T1. What is T2 and what is T1? T1 is the temperature at this position A. From A to B, the pressure is decreasing and the volume is increasing at isothermal process. This is an isothermal process. That means TA equal to TB. In isothermal process, the pressure is decreasing and the volume is increasing. So we can find the temperature at this PA. That can be T1. Okay, what is T2? T2 is the temperature at C. Then from C to D, the volume is decreasing and the pressure is increasing. Okay, so we can define the temperature T2 as in the C. So for what purpose I derived the case for the T2 and T1? For what purpose? To connect with the efficiency eta. For what is our need to find the efficiency eta? Eta have the relation with work. Eta is equal to work by Q. So what is Q? Q is given inside the question. The heat supplied to the gas is 8000 joule is the energy. That means it is the heat supplied to the gas to do the work. Okay, that work we want to find. Okay, and I am again saying that we have two isothermal process. From these two isothermal process, that means constant temperature process. From these two isothermal process, I am finding the temperature T1 and T2. Okay, now we can find what is T1. Pressure is given as 1600 kilopascal. So our pressure, the standard unit of pressure is in Pascal, so we need to change 16 into 10 raised to 5 Pascal. Okay, pressure is 16 into 10 raised to 5 Pascal. And what is the volume at that pressure? 2.5. Yes, this is 2.5. But the unit is per centimeter cube. The standard unit of volume is meter cube. So we need to change 2.5 centimeter cube to meter cube. So volume is equal to 2.5 centimeter cube. That is equal to 2.5 into 10 raised to minus 6 meter cube. Correct? 10 raised to 5 into 10 raised to minus 6 is 10 raised to minus 1, and 2.5 into 16 is 32 plus 8 is 40. 40 into, yes, correct. Okay, so just multiply this PV. PV is equal to nRT, and N is 1 mole because inside the question they are given as N is 1. So, N is 1 and R T1. So, T1 is equal to PV. PV is 16 into 10 raised to 5 is multiplied by 2.5 into 10 raised to minus 6 divided by R. So, T1 is equal to 16 into 2.5 is 32 plus 8 is 40. 40 into 10 raised to minus 1 is 4. So, 4 by R. T1 is 4 by R. So, next I am going to find T2. For the T2 is the temperature at C. Pressure is 400 and the volume is 6.25. So, T2 is equal to 400 into 10 raised to 4 into 10 raised to 5 is multiplied by the volume is 6.25 into multiplied by 10 raised to minus 6 divided by R. Okay, 4 into 6.25. 4 into 6 is 24 and 4 into 0.25 is 1. So, 24 plus 1 is 25. 25 into minus 1 is 2.5. So, T2 is 2.5. T2 is 2.5 by R. So, T2 by T1. So, eta is equal to, efficiency is equal to 1 by T2 minus T1. T2 by 2.5 divided by 4, which is equal to 4 minus 2.5 by 4. 4 minus 2.5 is 1.5. So, eta is equal to 1.5 divided by 1.5 divided by 4. We can put that in there. Okay, then we want to compare, we want to substitute that value inside eta is equal to work by Q. And what is Q? Q is given inside the question, and what is work? We need to find, actually work we need to find. So, work is equal to eta into Q, and what is eta? 1.5 divided by 4 is multiplied by Q. What is Q? 8000. So, 8000 divided by 4 is 2000. 2000 into 1.5 is just 3000. So, the answer is 3000 joule. Okay. So, which option is the correct answer? Option A is the correct answer. So, what we need to focus actually in here, two equation connecting the eta efficiency. So, two equation for efficiency is the fundamental thing in here. Eta is equal to work by Q. Q is the energy given, heat given to the system. Okay. Heat Q1, that means given to the system. And what is the next equation? Eta is equal to 1 minus T2 by T1. What is T2 and what is T1? T1 is the temperature for the isothermal expansion, that means the volume is increasing. Okay. And T2 is the temperature for isothermal compression. Okay. So, we can move to the next question. Question number 5. Yeah, this is also interesting. 100 gram of ice at 0 degrees Celsius. Yes. Is mixed with 100 gram of water at 100 degrees Celsius. So, equal amount 100 gram of ice and 100 gram of liquid at water. Water is in the liquid state, liquid at 100 degrees Celsius. Okay. 0 degrees Celsius and 100 degrees Celsius. Both are 100 gram, that means 0.1 kilogram. Okay. Weight or mass. Okay. Whatever it is, we can put that it is mass of liquid and mass of M1 and M2. We can give M1 for this 0 degree Celsius state and 100 degree Celsius state mass is M2. Okay, whatever it is, both are same. And LF and SW is given. So, the energy taken from, and actually the energy is going from high temperature to low temperature. The high energy means high temperature. So, in from 100 degrees Celsius, the What is mean by that? From 100 degrees Celsius water, the energy going from 100 degrees Celsius water to 0 degrees Celsius ice. So first, the what purpose, for what purpose does the energy is going? To change the ice from solid state to liquid state in the 0 degrees Celsius. Temperature change is not taking place that, so the energy is taking to change the phase, okay, that means the solid to liquid. Then the rest of energy is used to find the change from a 0 degrees Celsius water to a T degrees Celsius liquid, okay. Then the change in temperature only take place. First we need to change the phase, second we need to change the temperature. So for two purpose actually we are using the energy from liquid 100 degrees Celsius liquid, okay. So M1 into latent heat, the LF is given, latent heat of fusion is given. So M1 into LF plus M1 into specific heat of water. Then I am already said that first the energy is taken to change the phase, and the second one is energy is taken to change the temperature, and the final temperature is T and the initial temperature is 0, okay. And minus, why I did put minus? Because the energy is taken from what? Taken from where? The liquid state, okay, 100 degrees Celsius liquid state, minus M2 into SW specific heat of water into the final temperature is T minus the initial temperature 100, which is equal to 0. By why I put equal to 0? By law of energy conservation. Energy can neither be created nor be destroyed. So that's why the total energy is conserved from one place to another place. So that's why it is equal to 0. Okay, that is equal to 0. We can substitute M1 is 0.1 is multiplied by LF. LF is what? 3.36 into 10 raised to 5 joule per kilogram. 3.36 into 10 raised to 5 joule per kilogram plus 0.1 into SW. SW is 4.2 into 10 raised to 3 into T minus M2 is 0.1 into SW is 4.2 into 10 raised to 3 into T minus 100, which is equal to 0. Okay, just we can open this bracket. So just multiply in this equation. So 0.1 into 3.36 into 10 raised to 5 plus 0.1 into 4.2 into 10 raised to minus 3 into T minus 0.1 into 4.2 into 10 raised to 3 T minus 100, not T minus 100, 100 minus T. So why that is the 100 is the initial temperature, but that 100 degrees Celsius is the temperature in which it is stays as higher, so higher energy. So it is coming from higher energy to lower energy. So high temperature minus low temperature. So 100 minus T is the 100 minus T is the contribution term to the water which is in the higher state. Okay, so minus 0.1 into 4.2 into 10 raised to 3. So we need to change this equation from T minus 100 to 100 minus T. Okay, so then we can open our bracket, so which gives 0.1 into 10 raised to 5 is 10 raised to 4. So 3.36 into 10 raised to 4 plus 4.2 into 10 raised to 2T minus 4.2 into 10 raised to 5, okay, plus 4.2 into 10 raised to 2T equal to 0. Okay, 4.2 into 10 raised to 4, because the 0.1 into 100 is 10, 10 into 10 raised to 3 is 10 raised to 4. So 4.2 into 10 raised to 4. So 4.2 into 10 raised to 2 t plus 4.2 into 10 raised to 2 t. That means 8.4 into 10 raised to 2 t. 8.4 into 10 raised to 2 is, we can write 8400 t. Okay, then minus 4.2 into 10 raised to 4 plus 3.36 into 10 raised to 4. So that means 4.2 subtract 3.36 which is 4, and 11 minus 3 is 8, and 3 minus 3 is 0.84. 0.84 into 10 raised to 4 is 8400 minus 8400. Okay, 8400, and 4.2 into 10 raised to 2 is 4.2 into 10 raised to 2 is 420 only, and 420 plus 420 is 840. So 840 t minus 8400, which is equal to 0. So t is equal to 8400 divided by 840, which is equal to 10 degrees Celsius. Okay, so the final temperature is 10 degrees Celsius. Okay, then we can check with our options. Option D is the correct answer. It is 10 degrees Celsius. Okay, then we can move to the next question, the sixth question. Okay, pressure of ideal gas at constant volume is proportional to. Option A, total energy of the gas. B, average kinetic energy of the molecule. And C, force between the molecules. And D, average potential energy of the molecule. So in here, the pressure of ideal gas. So the pressure ideal gas equation is PV and RT. See, in here we can see the RT. RT means nRT is the component of energy in gaseous state. So E is proportional to kT. So that means the pressure is proportional to energy. Which energy? Average energy. Average energy is proportional to kT. So average kinetic energy of the molecule. Average kinetic energy of the molecule is proportional to the pressure. The pressure is proportional to average pressure. Not only the pressure, the volume is also proportional to average kinetic energy. Okay, in here the temperature is in Kelvin. Okay, in the previous question I have done the temperature in Celsius. Why? Inside that question, the change in temperature, that means SW, the change in temperature, the T minus 0 or 100 minus T. That's why we have done that question. We have done that in degree Celsius. Why we are not change the unit from degree Celsius to Kelvin? Actually, the LS, SW all are given in per Kelvin, but we are not using that Kelvin here. Why? Because this is only a change in temperature. Okay. If we are doing the calculation in Kelvin, we want to add 273 on here and here. So in net effect that 273 will cancel, and we don't want to bother about that 273. Okay, so we only want to do the calculation in just here, and also we want to put the answer in degree Celsius, not in Kelvin. Okay, the answer will also we get the answer in also in degree Celsius. Okay, so we can move to the seventh question. Okay, the speed of sound in an ideal gas at a given temperature T is V. V is the velocity, V is the speed of ideal gas. Okay, the RMS speed of molecule at that temperature is Vrms. Vrms, the root mean square value of the velocity. Okay, RMS speed of gas molecule. RMS is the speed of gas molecule, and V is the speed of sound. The ratio of the velocities V and Vrms for helium and oxygen gas are X and S dash. So X is nothing but the ratio of V and Vrms. X is for helium and yes, V and the ratio of the velocity V and Vrms for helium, and X dash for the ratio of V and Vrms for which atom? Oxygen atom. Okay, oxygen gaseous, and X dash respectively. So the ratio between X and X dash. So we have to find the X divided by X dash. So what is the relation? Which relation connects the V and Vrms of a molecule? It is nothing but root of gamma by 3. What is gamma? Gamma is the ratio of specific heat capacities. Cp by Cv is the gamma. How we can find the gamma? Gamma is nothing but 1 plus 2 by F. What is F? F is the degrees of freedom. So what is the F? What's the value of F for helium atom? See, helium and oxygen. Oxygen is O2 and helium is just helium. So helium is monoatomic. So degrees of freedom for monoatomic is 3. So F is 3. 2 by 3 plus 1 is 5 by 3. So gamma is equal to 5 by 3 for helium. And gamma is equal to for O2. Oxygen is diatomic and it is rigid. So degrees of freedom is 5. So F is 5. 2 by 5 plus 1 is 7 by 5. 7 by 5 for O2. So we have to find X by X dash. Is it correct? The ratio between X and X dash. X by X dash, which is equal to Vrms V by Vrms of helium divided by V by Vrms of O2, which is equal to root of gamma by 3, gamma helium by 3 divided by root of gamma O2 divided by 3, which is equal to root of gamma helium divided by gamma O2. And what is gamma helium? Well, gamma helium is 5 by 3 divided by gamma O2 is 7 by 5, which is equal to root of 25 by 21. So root 25 by 21, there is no options like that. So we want to change the root 25 into 5. So 5 by root 21. 5 by root 21. Option D is the correct answer. Okay. So we can go to the next question. The eighth question. Heat cannot be itself flow from a body at low temperature to a body at a high temperature. This statement corresponding to. That means heat cannot flow from low temperature to high temperature. Heat only flow from high temperature to low temperature. This is given by the entropy delta S. The entropy delta is always greater than or equal to 0. Delta S never can be negative because the universe is expanding. So that means the entropy is a positive. The entropy should be positive. That means then if the entropy is positive, heat can only flow from high temperature to low temperature, not low temperature to high temperature. If we want to flow, if we want the case from heat that should be flow from low temperature to high temperature, then we want to give an additional energy. This is the basic principle of a refrigerator. The heat should be flow from low energy to high energy. Low energy inside the refrigerator and high energy is the outside. So energy should be flow from inside the refrigerator to the outside. In that case, we need to give additional energy in the form of electrical energy. Okay. So this is second law of thermodynamics. Option B, option C, delta is greater than or equal to 0. Okay. And delta is change in entropy. And we can move to the ninth question. Which of the following curve represent the variation of coefficient of volume expansion alpha V? Alpha V is the coefficient of volume expansion Okay, ideal gas at a constant pressure, the pressure is constant and the x-axis is T or 1 by T. So we need to find the relation between alpha V, that means the coefficient of volume expansion with respect to temperature. So what is the volume of the coefficient of volume expansion? Alpha V is nothing but change in volume by original volume, change in volume by original volume into change in temperature. So actually that is change in temperature, not temperature. So we want to do some modification to make the delta T as into T. So we know that ideal gas equation PV is equal to nRT. So P into del V is equal to nR del T. Okay, so P by nR is equal to delta T by delta V. Okay, so delta V by delta T is nR by P. nR by V is delta V by delta T. Substitute in the above equation. Delta V by delta T is nR by P. So alpha V which is equal to nR by PV. Okay, and PV is equal to nRT. So nR by nRT which is equal to 1 by T. So alpha V is equal to 1 by T. Alpha V is proportional to 1 by T, directly proportional to 1 by T. So which is the correct option? Option B, directly proportional. Alpha V is directly proportional to 1 by T. Option B is the correct answer. Okay, so we can move to the next question. 10th, a number of Carnot engines are operated. Identical cold reservoir temperature TL. Okay, TL is the temperature in which the temperature is very low. That means the cold reservoir. Okay. However, their hot reservoir temperature are kept different. Okay, the hot reservoir which the temperature is higher than the cold reservoir. Okay. A graph of the efficiency of the engine versus hot reservoir temperature TH is plotted. Okay, when TH increases, what happens? We know that the efficiency eta is equal to 1 minus, that means the when the high temperature increases, the efficiency should increases T2 by T1, and which is equal to 1 minus T low temperature by T high temperature, the efficiency. That means when TH high temperature increases, the efficiency should increase. Okay, and to a limit, up to a limit only. So from the first graph, when TH equal to TL, when TH is equal to TL, it is increased, but when TH is equal to TL, it is 1. So 1 minus 1, which gives 0. So when TH equal to TL, it gives 0. So option B, C and D that gives. Okay, and after that, when TH increases, TL by TH is decreasing. Okay, so 1 minus yes, that means when TH increases, the efficiency should also increase. That means if this increases, the efficiency is increasing, and TH increases, the efficiency is increasing, and this can be the wrong one. And option B and option C are looking like a correct options, but in C, when TH increases, the efficiency is continuously increasing, linearly increasing, but that is incorrect, because when TH is go to an infinite value, then TL by TH is equal to 0 and the efficiency become 1. Okay, after that the efficiency can't greater than 1. Okay, so up to a limit. So option B is the correct answer. Okay, so we can move to the next question, 11th question. A gas mixture contain monoatomic and diatomic. That means a gas with a different gamma specific heat capacities are mixed. Molecules of 2 moles each. both are two molecules that directly given n is equal to 2. The mixture has a total and internal energy of, so we are bothered about the internal energy U. So and du is u is given NCVT. Okay, NCVT. What is CV? CV for monoatomic. CV for monoatomic is equal to 3R by 2, and CV for diatomic is equal to 5R by 2. CV for monoatomic is 3R by 2 and CV for diatomic is 5R by 2. So total internal energy U is equal to 2 into CV. CV is what? 3R by 2. Okay, 3R by 2 into T plus 2 into 5R by 2 into T. That means 2 and 2 cancel. 3RT plus 5RT is 8RT. 8RT. Option C is the correct answer. Okay. So, thank you.